Okay? Our goal is to finish 8.1. We are going to get to play with our calculator a little bit, but some of these our calculator can't do as much as we can. But this is the last by hand problem, so hang in there. We're going to do one really big problem today. All right? We're going to do one really big problem today and then bust it out kind of little step by little step. Yesterday, we were talking about how this RREF, which is called Gauss-Jordan elimination, reduced row echelon form, says if we can get this guy all the way down to the identity matrix. Yesterday we stopped short. Yesterday we went only to row echelon form. We left this number in there. We got a leading diagonal or main diagonal of 1, zeros below. We didn't get this guy to be 0, so we had this extra step of plugging in and solving. But what I showed you at the very end yesterday was if we had just kept going, what's called is reduced row echelon form, if we had gotten all the way to the identity matrix, we actually wouldn't have to do any extra work. We would have set up for us what the X answer is, what the Y answer is, what the Z answer is, as long as it's a consistent system with just one solution. So if we just keep going, following the exact same steps that we started yesterday, but not just getting the 1s and the 0s below, but also the 0s above, then we'll go ahead and be able to solve for our final answers. Now here's something that we need to say with the identity matrix. Remember yesterday in the notes, and I mentioned it once today, when we're doing RREF, we have to work by rows or by columns. Thank you, Vicki. By rows or by columns? Ooh, look at your notes. The example from yesterday, did you write it down? Put a little star by it because a lot of you just forgot it. Go back to where we did row echelon form with that little two equation system. And I said work by columns. And when we're working by columns, do you remember what we start with? Getting the 1 or getting the zeros? Getting the 1. So we're going to make sure that we have a 1. Then we're going to finish that column by getting the zeros. Yesterday in the notes, did we talk about how to get 1s and how to get zeros? Okay, turn to the example from yesterday. Do you see where we wrote getting 1s? Okay, how do we get 1s? Good. Divide the whole row, every single entry, by the number that's there. Otherwise known as multiplying by, and I think we had to do it here, multiplying by the reciprocal. So whenever we want to get 1s, we were getting 1s here, and we were also getting 1s here. Whenever we get 1s, we multiply by the reciprocal of whatever's in that spot, or we divide by that. Now, how do we get zeros? We add. Good. But we can't add as is. We take whatever has a 1 and multiply it by the opposite. Good. The negative or the opposite of what we're trying to get rid of. So we get a 1 first, then we multiply by the opposite and add and get zeros. That's exactly what we're going to be doing today, kind of over and over again. So first things first, you guys have our first column. Pause. I apologize. Does it make sense how this matrix came about? Okay. And in this spot, we put a good. Now, as we come down, first column, we need to establish what first? But what's the good news? Go, team! All right, well, he's fine. He's fine. So we're going to go ahead and keep that row. 1, -4, 3, 5. For the first column, the first row is set because it already has the 1 that it needs. But the second row and the third row are not set. Because what do we need in those spots instead now? Zeros. How do we get zeros? We multiply. Good. By the opposite. And what's the opposite of this guy? Positive 1. And we're going to add to row 2 into row 2. And the nice thing is, guys, we can do two things at once. I'm going to do something very, very similar for row 3. What am I going to multiply row 1 by to get rid of this guy? -2, row 1, plus row 3 into row 3. Now remember, we have to do this step by step, right? Term by term. I'm going to do one full row first because then my mind kind of gets this pattern, this formula in its memory bank, and it can just kind of apply it over and over again. Then we'll do this whole row. So we have to do every single entry. Now this is kind of easy. It's just 1 times, and then you add. So what's 1 times 1 minus 1? It's as easy as 1 minus 1, right? 0. Remember, we're just multiplying by 1. So what's negative 4 plus 3? 3 minus 1. Keep going. Keep going. Keep going. For the second row, we're literally just adding the 2 together, aren't we? So then did you guys get 2 and then 2 to finish off? Okay. We have a 1, we have a 0. Jacob. Oh, we're adding each corresponding entry of row 1 to row 2. For the purpose of, we chose the opposite sign, so positive 1. And then we're just saying, okay, so 1 times that plus that, which ends up being that plus that. So first entry of row 1 plus first entry of row 2. Second entry of row 1 plus second entry of row 2. We're just adding the 2 together, kind of like a big ol' elimination. We're going through. It's going to change for this one, though, because we couldn't just say 1 times row 1 plus row 3. We couldn't just add these 2 together because it wouldn't be 0. So that's why we have to do this little row operation of saying, nope, nope, nope. We need all of these to be multiplied by negative 2. Noah, you had a question. Yeah, because we're only trying to get this 0, and what we do to get that 0, we have to mimic the whole way down. Kind of like distribution for equations, we have to do the same thing for everything. So it's working to get a 0 here, and then we just have to kind of finish off that chain reaction for the rest of the equation. Does that make sense? Now, this one, some of you mental mathers, let's see if, oh, Joel, sorry, go ahead. Exactly. Exactly. And don't worry, you'll see, we'll have to do this a few more times because we have 3 columns to work on. This one's like accumulating our answers. So this negative 2 for mental mathers, take every piece of row 1, every entry, multiply by negative 2 and add it to the corresponding row 3. So negative 2 times 1, negative 2, plus 2, 0. Negative 2 times, I have to do it again, negative 4, plus 0. Mental mathers, finish. Non-mental mathers, that's a lot of math. So maybe it'd be a little nicer to put into our workspace over here, hey, let's take row 1 and let's multiply by negative 2. Negative 2, positive 8, negative 6, negative 10. I just took row 1, multiplied it by negative 2. I'm going to write the row 3. You can do the math off to the side if the mental math isn't going to work so well. You can actually take row 1 and multiply everybody by negative 2. Take row 3 and say, all right, let's put them together. For mental mathers, it's something that we can maybe do in our heads and not have to show all this extra work. Or a computer can definitely do it in its brain, right? It can do it in its programming and not need to show this extra work. But we're humans trying to kind of mimic the process and figure it out. So you can show this work and you would get 0, 8 mental mathers. Did you get negative 10 and then negative 4? Good. So you could show the work, or you could try to follow the process of negative 2 times 3 is negative 6, minus 4 is negative 10. Negative 2 times 5 is negative 10, plus 6 is negative 4. It's a numbers game. Do we have our first column? All we need are 2 more. Okay? But when we go to the second column, what's our first job, our first priority? Getting the 1. Where? Oh, wait, it's so close to being a 1, right? But just to follow our procedure, first of all, we can't touch row 1 yet, or row 3, because we don't get the zeros until we get the 1. So I'm going to keep row 1. I'm going to keep row 3. The guy that we need to change is row 2. We're humans, so we could say, just multiply everybody by negative 1. That would work, right? To get a 1, we always want to multiply. You could even think multiply by the reciprocal. So if you want to think of how our notes would have said it, you could have done 1 over negative 1 times row 2 into row 2. We could multiply by the reciprocal. It would still work. Ultimately, what are we going to do to every single term? Switch its sign. Multiply by a negative. Yeah. So 0 times negative? Our system works. The 0 stays. As long as we follow our steps. The systematic approach of getting 1s and getting 0s, we will never mess this up. It'll stay where it needs to be. This one's going to flip sign, flip sign, flip sign. What I do to one, I got to do to them all. But do we have our 1? And the answer is yes. Once we have our 1, what do we need to get? And how do we get zeros? As you guys are thinking, let me write the row with ones. With the 1 in the proper spot. Row 2 is staying the same. It's time to tackle the zeros now. What am I going to multiply row 2 by, adding it to row 1 in order to get the 0 where I need it to be? Not negative. Sorry, row 1. Positive 4. I heard it from a couple. Does it make sense it needs to be a positive 4? What am I trying to get? 0. Positive 4 plus negative 4? Got it. So take a second, write the little formula for what we're going to do to row 3. Let's see if you can apply what we just did to get row 1 to be a 0. What formula would you write for row 3? Follow similar logic. Some mental mathers, you might already start trying to do what you need to do. Jackie, what do you see, Kara? We're trying to get to that, oh, you missed it yesterday, but let me show you at the bottom. A peek behind the curtain. We're trying to get it to look like an identity matrix, which has 1s in this diagonal and 0s everywhere else. So we just got this column. Now we're working on this column. We have him. We need 0s here and here. So that's why we multiplied this 1 by a positive 4, and we're going to add it to all the row 1s because that will cancel this negative 4 out. Does that make sense? So what do we want to cancel out in row 3, guys? The 8, right? How are we going to cancel out the 8? Yeah, by multiplying by a negative 8. No, I just realized that I didn't have. I did. Because we were painting him last night. Oh, you're making 3 more. You're my hero. Yeah, go ahead and take one. Thanks, bud. And then those 3 you can stain if you want. Yeah, 3 more. That would be perfect. Just take one of the long ones. Thanks, bud. If you guys just noticed, I realized I do not have near enough of these guys because I'm going to run out of space, yeah? So let me go ahead and... Sorry, guys. Cameron's helping us on a mission project for the fundraiser coming up in 2 weekends. Let me come back here. We need some more of these guys. Not exactly sure how many, but let me get a few more. I think that'll be enough. If we need more, we'll get more. Okay, so what'd you guys write down for the third row? Good. Negative 8 times row 2. I'm hearing it. Plus row 3 into row 3. You're just kind of setting the goal. Where am I trying to go? What am I trying to do? Okay. When we multiply row 2 by 4, my non-mental mathers, you might want to write this out, and I'll show that in just a second. My mental mathers, you would have to start at the very first entry of row 2, which is this 0. If we multiply this by 4 and add to 1, what's 0 times 4? Plus 1? We're maintaining the first column, which is exactly what we need to do. What's 4 times 1? Minus 4. Perfect. Mental mathers, keep going if you haven't yet. Taking it term by term. Non-mental mathers, you could literally put over to the side. Okay, I need to take this whole row 2, multiply it by 4. So I'm going to go step by step. 0, 4, negative 8, negative 2. I need to add that to row 1. You can actually show this math. It's okay. You can use workspace. Then you would end up with 1, 0. Mental mathers, check. Negative 5 and 3. Do you agree?
Yes. No. That's negative. That's negative 3.
Because?
Because you have a negative.
Good. I was talking too much and focusing too little. I think there's a proverb about that. Anyway, Even the fool when he's silent seems to be wise. I need to apply that a little more. But 4 times negative 2, good, would be negative 8. So then when you add negative 5, when you add negative 3. Good. Do you see how easy it is to make mistakes? Uh-oh, I just uncovered something. I'm not sure what. Ignore it. I don't think it was supposed to be there. Okay. We still need the bottom row, right?
Yeah.
Negative 8 times 0. 0 plus 0. 0. Hey, hey. Oh, that's right. It's supposed to stay. Negative 8 times 1. Plus 8. Can I keep mental mathing? Is that okay? That's the way I do it. Negative 8 times negative 2. 16 minus 10. Positive or negative? Good. Oh, looks like a negative. Well, that's fun. If I erase, I'll find other random numbers. Negative 8 times negative 2. 16 minus 4. Positive 12. Non-mental mathers, you could have gone off to the side and written it all out. That's okay. Second column. Done. Third column. What's our objective? Get the where? So I'm going to write the first 2 rows and say I can't mess with them yet. My only objective is to get the 1. So 0, 1, negative 2, negative 2. All right. How am I going to get a 1 in that third row? Divide by 6 or multiply by 1/6. What happens when you divide 0 by anything? Oh, 0's stay. What's 6 over 6? What's 12 over 6? Hey, z equals 2. Let's back substitute. No. Let's keep going, and we'll have our answers without any back substitution, writing z equals 2 and y minus 2z equals negative 2. Let's just keep going. So we have the 1. Now what do we want? Zeros. How do we get zeros? Well, first of all, row 3 is solid. We're good with him. Row 1 and 2 is what we need to cancel out. Take a second. What 2 formulas would you write to get rid of what's there and get zeros instead? It's using the idea of this right here with the 4 and the negative 8. Take a second. What would you write for rows 1 and 2? We actually don't need this guy. Okay, pause. Check in your groups. You might not be totally done, but do you have the right idea? Did you get one of them? How'd you write it? How'd they write it? All right, I'm going to start playing with it, if that's okay. First, let me write the formula so you guys can make sure you're doing the right thing. But if you have the right formula, maybe you were able to keep going. Did you guys do 5 row 3 plus row 1? And 2 row 3 plus row 2? And then, can I do some mental math? You guys already going on it? Okay, those who aren't going, go ahead and start. Because we're going to have to take, what do you think, row 1 first? 5 times 0, 0, plus 1, 1. 5 times 0, 0, plus 0. Okay, keep going. Don't just do that one, try to do the second row. See if you can beat me. What we want is hopefully an entire identity matrix with the x, the y, the z at the very end. I want to play, but I want to give you guys a chance first. If you think you have it done, go to your calculator, put in the original matrix, and then go to that cool matrix math menu where the REF was, and go find for me the RREF, and see if your answer matches its answer. Depending on the year, sometimes we've made a mistake, but you guys have been keeping me pretty honest, so think we should be good. Remember, you can check in your calculator, putting the original matrix in. The calculator is doing the math that you just did very quickly, obviously, when you do the RREF feature. Ten minus 3 is 7. You guys get 7? 0 plus 0 is 0. 0 plus 1 is 1. 2 minus 2 is 0. 4 minus 2 is 2. If you're able to get it to the identity matrix, what you've just done is figured out that this top number is your x. 1x plus 0y plus 0z is. The second one is your y. 0x plus 1y plus 0z is 2. This third one is z. 0x plus 0y plus 1z is 2. Final solution, 7, 2, 2. But you're trying to see if your calculator can show you the same thing, aka if we're right. Jacob, what's your question first, though? Oh, you can always go back and say, okay, what was the formula? Multiply the third row in that placement, that column, by 5, add the first. So multiply this third row, this column, times 5, 10. 10 minus 3 is 7. You see it? Okay. Oh, there you go. There you go. Yeah, the signs can get really messy when we're doing mental math. But if you can get the hang of it, it actually goes kind of fast once you get the hang of it. Guys, what size matrix did you have to make this original guy? 3 by 4. Careful, right? 1, 2, 3, 4. Have to get everybody in or else it won't know what to do. So you guys hopefully did the edit feature. You hopefully made it a 3 by 4, rows by columns. I wish my calculator would let me type in negatives, but it doesn't like negatives. Okay. How'd you guys find the RREF I was talking about? Good. Second, x negative 1 matrix. Now, math. And if you guys scroll down, I know mine has a lag, so it's going to take a little while. The REF is down there. We saw it last chapter, but then underneath the REF is RREF. It says, hey, if I can go all the way, I'll go all the way. To who? Remember, go get the matrix that you made. And if all goes well, boom. Was it magic? No. Someone programmed it to do the steps that you were doing by hand. And if you work column by column of any size matrix, getting the 1s and 0s, then in the next location 1, then 0s, next location 1, then 0s, using our getting 1s, getting 0s formulas, you'll always, as long as it's solvable, be able to get there. Maybe kind of cool. It's a way to tell a calculator how to solve a system every single time. Now, have we ever seen systems, though, that don't have nice, pretty single answers? Do you remember something to do with A's? Okay. We just saw what the calculator can do. So, let me give you, look at the directions. Go, team. What do you get to do? All right, go straight to making the matrix out of this system of equations. If you're going to solve, why not just use RREF, which goes all the way if it's possible? REF, we'd still have to back substitute. Michael, here's the test. I gave him 2 corrections. All right, go for it, guys, if you haven't yet. You have to change that matrix, that system, into a matrix. What's your second row supposed to be? Good. 0, 2, negative 3, 14, right? And then try to do RREF. Chris, what's your question, bud? All right, I'm going to go to my matrix 2, or my calculator, and start plugging in because I want us to look together at what's going to happen, whether good or bad. Jackie, what's your question, kiddo? Oh. Yeah, and then you're just putting in the coefficients, and if anything's ever missing, like the second row, just a 0. Now, careful. This one, it wouldn't be 0, 7, it'd be 7, negative 5, 0. Yeah. Okay, if you guys quit, as long as I put it in right, I don't know, I had some issues somewhere in between. RREF, is that letter B, guys? Okay, thanks. Alpha B, it's faster than me scrolling there. And then I have my matrix. I just keep using the same one. That's not what I want. Second, matrix. What happened when you did RREF? Would that have been a fun one to do by hand? No. How do we even write the answer? I mean, I guess, can you guys see that there's this little arrow over to the right? I guess we can scroll, but, oh man. Say what? Is there a cool button in our calculator that allows us to take decimals and change them to fractions? I wonder if it knows how to do matrices. Anybody see anything that might be helpful in the math menu? Let's go to fractions, huh? And guess what? It does know matrices. It does know matrices. So if we're allowed to use our calculator in the RREF and use the wonders of technology, we could, well, hold on. We don't even have to write x equals y equals z equals. Can't we just show it as a point? So do you guys have the fractions for me? I just lost mine. It was 190. Good. What's the second one? Good. The last one? Got it. Pretty cool that someone figured out how to program that in a system that would always work. Now, always work. I keep on adding this little extra note at the end. Always work as long as the system has one solution, one intersection point. What's going to be harder as soon as we get to this guy, number 71? I want you guys to try plugging them in as is. Okay, fine. We learned this RREF and he's super, super cool. My warning is something is different, but I want you guys to figure out what's wrong. Go ahead and plug this guy in. What size is he? 3 by 3. All right, go for it. 3 by 3. Try the RREF feature and see what happens. I'm going to do it over here, but I froze the screen. There is no C. You're seeing what happens, though, if you were to plug in this, which is a homework problem, or like one. Let's see what happens when we try to do RREF to a 3 by 3. Do good things happen or bad things happen? Where are our answers? Okay, does it work with a 3 by 3? Would it work with a 2 by 2 or a 4 by 4 or a 5 by 5? It needs a constant column that's separate from, it's used to normal, or the programming's only made for normal systems where you only have as many equations as you have variables. Now, there are a few different ways that we could tackle this. One way is we just could take the first two, find its solution. The last two, find its solution, because 2 by 3s will work. But the problem is we need this one solution and that one solution and that one solution, and hopefully they're all the same. If they're not all the same, maybe it's one of those weird pictures where it's like the tent of cards and there's no intersection in the middle, if you guys remember that picture from last chapter. Another way of doing it, and you're like, well, okay, it doesn't handle it because there's no z column, right? Isn't that the problem? What would happen if we went to our matrix and actually said, okay, there's no z column, let's put that in? Isn't it when there's no anything we put a 0? So couldn't we go down to our matrix and couldn't we say, okay, what happens if we make it a 3 by 4? And what happens if we come here and say, you know what, that's a 0, 0 z's. That's a 0, 0 z's. And that's a 0, 0 z's. Because at least now it's the right dimension. Maybe it'll like us better. So we have negative 22, we have 4, and we have 32. So maybe the problem is we just didn't think about what the calculator was going to see this as, and we need to actually put 0z, 0z, 0z. Now we could try. Is it any better? It actually just got a whole lot worse. What just happened? If we read this, we get x equals 0, 1x equals 0, 1y equals 0, and 0z equals 1. Well, that's new. Does 0 times anything ever equal 1? Huh. But guess what that tells us? A false statement says, you know what, good try. If we had done these two, and those two, and these two, there would have been no common single intersection point. Does that kind of make sense? So the calculator can help us, but we need to know how to use it. Does that kind of go along with what we've been doing? So it needs a 3 by 4. It needs a 2 by 3. It needs the dimension to be, the order to be a little bit off. It can't have a square matrix like this. It can't deal with it. So wait, thinking along those lines, if we just had to add a 0 column here, then question, what do you think we're going to do over there? Add a 0 row. Ready, set, go. This one was missing a column, so we put in zeros. This one is missing a row, so let's put in. All right, let's see if the calculator can help us with this one. We saw it in chapter 7, section 3. We saw non-square systems. I'm going to go put it in 2, but let me leave it on the screen for you to see. Okay, good or bad? Okay, so it's not a no solution. We know that, right? Because it's not a false statement. 0 equals 0. If it's not a false statement, wait, what did we do in chapter 7, section 3? If everything canceled out and it wasn't a false statement. Kind of all solutions, but they're still limited. Let z equal a. Yeah, let z equal a. Now, kiddos, hold on. Normally, if z equals a, if we had this only and we said, okay, fine, z equals a, aw, stink. Like, we'd still have to do some sort of row echelon, stair step, trying to cancel stuff out. So our calculator is going to help us kind of. Can you guys tell me the matrix that it gave us? It gave us something good. We just have to go a little bit further from it. It gave us 1, then, okay. So it wasn't able to finish because it couldn't get the 1. And if it couldn't get the 1, there's no reason to get zeros, or there's not even a way to get zeros. It's impossible. Well, this actually is reduced row echelon form. It's impossible to get any better or any closer, but look, if I just replace this bottom row with z equals a, and I say that this is z and this is y, didn't my calculator kind of make it so all I have to do is plug and chug? Here I would have had to still kind of like do a whole system of elimination and cancel out the x's and get the y's and z's. Here it's like, oh, it got me part way. How do I get y? Plug it in, plug it in. Good. So y plus 9 times a equals 1, so therefore y equals 1 minus 9a. That looks like 9q. Anyway, how am I going to get x? Plug in who y is, and oh wait, who's y? Doesn't matter. It's just 0. So therefore x minus 5 times a equals 4. So x equals 4 minus, no, plus, good, 5a. That's an a. So at the end of the day, we have 4 plus 5a. So could we still have weird things that happen, even in this section? Yeah, because some matrices are inconsistent, no solutions at all, and some matrices are consistent, but infinite, so I have to still do my z equals a. But can the calculator still help you get partway there? Yes. Can row echelon form, if you were doing it by hand, still help you get partway there? Yes, but if you ever once again get a row of zeros, we got to let z equal a. Or if you have a row that's illegal, that's false, just say no solution, because it's going to be impossible. Kiddos, with that, we're done with 8.1. I'm going to have you guys just take the very first page of 8.2 because it's short, as I pull up the 8.1 homework, just in case you want to take a quick picture of it as you leave, if you haven't yet gotten it written down. 8.2, we're going to say, okay, we kind of see that matrices can be used in computer programming for systems of equations and solving. That's kind of the gist of 8.1. But now that we've seen that matrices can be used, we're like, oh, there's this whole thing called a matrix. We're going to, in 8.2, just say, okay, what are the basics of matrices? Kind of like with vectors, in the sense of, don't worry, it's not like vectors in that it's a very different thing. But with vectors, it was like, oh, there's a thing called a vector. Oh, it does stuff like forces or velocities or tension or... Okay, then let's talk about it. What are the parts of a vector? How do we add vectors? How do we draw vectors? So that's kind of what 8.2 is about. What's a matrix? How do we add them? How do we subtract them? Can we multiply them? Just having us get a little deeper into this thing called a matrix. Kiddos, keep an eye on homework when you get there. It will tell you when you're allowed to use your calculator. And even for evens, you can check on your calculator. I totally support that. That's fine. But some things you have to be able to try by hand. Because we're trying to show you not just there's a cool program, but oh, hey, someone made it. And how they made it was they figured out this general way of always solving a system. Okay? So play with some things by hand when you're asked to. Play with it in the calculator when you're asked to. It is a cool tool, and we are going to use it. But we also want to see behind the scenes, too. Here's section 8.1 homework. If you guys want to go ahead and either write it down in your spiral or take a quick picture of it, you may. This would be a productive way of quickly accessing using your phone during class. Unproductive ways we were asked in